can see my screen. It's written there, cybersecurity workshop. And I hope you guys are all doing well. Today we are just a quick caveat or disclaimer that this workshop we wouldn't claim it is like an entry level workshop, because this would like cover a little bit deeper in PE, and also how do we do various kind of process injections, which will be demonstrated later after I talk so much about it, and we will see a demo session or hands-on session right after the I have explained what is actually a PE file. So the first part is gonna be quite I'm gonna say it's quite boring if we spend too much time on it, and next would be a hands-on session. And yeah, I guess we can start. So first of all, before we start, we want to express our appreciation to NanoSec, also Rehack, for giving us this opportunity, because to be honest, without them, we wouldn't be able to like learn this stuff, because me and Ali, we are able to like learn so much from the course, and today is the time where we want to like give back and teach other what we have learned. And yeah, thanks to them. And next is a very brief introduction of who will be speaking today. There will be two person in as a speaker for today, which is me and Ali. And also I'm going to like introduce myself first. There is no bullet points for this one, so I'm just gonna like talk through it. My name is Aniq Fakrul, or people know me in the Discord or other platform as CH4M Charm. And just a quick like how do I get myself involved in InfoSec. We actually started like 2 years back, since the early pandemic. I guess it's everyone I explain about it, I just keep saying 2 years. I'm guessing it's 2 years plus now. So how do I get myself in InfoSec is I get to know, I joined like the first workshop, which is the RE workshop that I know nothing about. And I got myself interested in InfoSec, and I joined the same server as Ali, and we started exploring together, like back to back, day to day, and daily basis. And yeah, hope you guys enjoy the session. And before we start, I'm going to like let Ali introduce himself first.
Yeah, hello everyone. Good morning. So my name is Muhammad Ali Akbar, but you can just call me Ali. Usually in internet, I use my alias Hujan. And how do I get involved with cybersecurity? Also the same with Aniq. In 2020, early pandemic, I first joined workshop from my senior related to reverse engineering. And from that, I tried to explore more with the community itself. And that's how I meet Anik and others. And since then, we try to help each other. And what I could say is that from community, I learn, and that's where we help also the community, so that more people would join the cybersecurity area and maybe could put it as their future career. And yeah, I think that's all about me.
Okay, I guess we want to jump right in, because today is Sunday, so
Yeah.
we don't want to like drag time. And let's start. Oh, just a quick disclaimer that uh anything that we will show today on the slides uh, cannot be distributed I mean, just read the disclaimer. 1 minute and I'll start. Okay, that's the 1 minute. Okay, so let's jump right in the PE structure. So just PE stands for, also I forgot to like tell that PE stands for portable executable. That anything that let's say it is actually an exe file. So PE like contains of two parts. In the, it can be like, you can see it is it has the header part and also a sections part. 1 moment. Okay, so header is actually you can imagine like this, like header is like a table of contents in a book that contains all these 1 2 3 4 5 other stuff, and section is like chapters in a book. Okay, so I'm going to like walk through the header because in this section is not really important for us to like parse through. This all contains the code and everything, and we want to look at the header. So in the header, we can see that it has a DOS header, it has a PE header, optional header, data directories, and also a sections table. And the first one is DOS header, is like it shows where the PE header, it shows the information that it is a binary, it has a magic number, blah blah blah, and it points. This is important because we want to point it to the PE header, so we know where the where the PE header located. And PE header, just imagine like it is like a road sign. Actually, it contains pretty much everything. Let's say if you are driving on the road, you see a road sign, and the road sign tells you that if you want to go to JB, is you have to follow this road. If you want to go to somewhere else, you have to follow the left road or right road, blah blah blah. So PE header is like a road sign, and the optional header, it contains a lot of stuff that I will cover later. The important part in the optional header is we want to look at the import and export directory. I'm going to explain very briefly what is import and export. Import directory is, for example, if you code a C++ uh, binary or application, in order for you to call an API, you have to like resolve it from other DLLs, right? For example, if you want to use like a write process memory API, you have to get it from system32 or NTDLL. You have to get it from others. So that is called import directory. Export is where you provide API for other binary to use. So most of the time, not necessarily like every time. DLL is normally provide API for other, right? So it has a lot of stuff in export directory, and normally exe that use API from other DLLs, it is called import directory. I will cover that later. And in the sections table, also I will cover later. It contains a text section actually of more of assembly stuff that we don't actually care about to parse a PE header. So let's jump into the hands-on session. I might be a bit rusty on this, so please bear with me. Okay, so I'm just going to load it one more time. Unload. Let's load a normal notepad.exe process. So we have loaded a notepad process, and I open a winnt.h .h here. Sorry, that contains definitions or structure of the required structure in PE. And let's take a look at a DOS header, the first part, right? So DOS header, we can see this is the structure of a DOS header. We can see it has a, oh, by the way, this tool is called PEBAR. Is a really great tool that actually already uh, does the parsing for us. So what we want to like do now is like understand how this tool parses these uh, like numbers or attributes in the header. Uh, so if you don't want to like headache or pening kepala, just use this tool and look for the necessary stuff. Like it already parsed all the headers, like optional headers, section headers. But we want to look at it manually. So for the DOS header, it is under image DOS header structure. So we can see that in PE header, it already said the magic number bytes on the last page of file. This is the in the back end, like the magic number consists of 5A, 4D. You can see over here. Wait, see if I can view. No idea how to view on the left side. So for the magic number, we can see that 5A, 4D here. Word is 2 bytes, right? So here is 5A, 5A, 4D. And we can see the next part is ECB LP, which is bytes on the last page of file. Also 90 here, over here, 2 bytes. And the list goes on 2 bytes, 2 bytes, 2 bytes. And the important thing in the when we are parsing PE file, we are when we are parsing PE headers manually, is this like this stuff like ELFA new. You can see it is at the last part of file address of new exe header, like I mentioned before in the slide. Right. We only care about PE header, and how do we get to PE header is through DOS header, because DOS header tell us where the hell is PE header. Okay, so this is it. So we can see that F8 over here. I think it's over here. F8. It is the ELFA new, and let's follow into the raw address. Okay, so we land on the PE header, the NT header. So we can, let's see if it has any definition in here. Okay, so we have a NT header in here, image NT header 64. It depends on what type of uh, PE header that we are parsing or using. This can be a 32-bit PE. It can be image ROM headers, and in this case, we are loading a 64-bit PE. So it is using a structure of an image NT header 64. Okay, so we can see that this structure consists of so let me go here first. Okay, so this is the NT header in the PE file. So you can see it has a I'm sorry, this is only file header. One moment. Let's just go manually, right? So the first part is 4 bytes. It contains a signature. You can see 4 bytes here. It's 4550. And it is in the string section, it is stated that it is a PE file. And in the characteristic, let's see. So we are jumping into the file header part, right? This one. This one, let's see. So in this one, we have other information about this VE. We have this like machine information, number of sections, 2 bytes, time date stamp, 4 bytes, and also 4 bytes for this one. And let's see the characteristic. Okay, the characteristic you can see is 22 over here. It consists of 2 and 20. You can see the definition down here. If you guys have question, you guys can just stop me. Okay, can ask me. Okay, let's see the 2. So it is stated that it is a image file executable image because it is an executable image. So it is 2, and you can see a 20. What is 20 in? So it is somewhere in here. It's 20. I have to use a calculator for this one. But the characteristic contains this kind of information in the definition part. You can see in the winnt.h file. And let's move on to like, one moment. Give me like 1 minute. Okay, so the only important part is, like I mentioned in the slide, that we only care about the optional header, right? It contains a lot of information in the optional header. And let's say if we are starting from scratch, we want to parse PE headers. So we only have a DOS header information. Okay, let's jump into new exe header, which is the NT header. And we can see that, one moment. Okay, we can see that we can jump to the new exe header, which is already did. And the file header, we can add, wait, if we want to enter the optional header, we have to add 24 bytes, which is 4 bytes for signature and 20 from file header. Okay. Oh yeah, why am I saying this file header is 20? Because you can see that it's already defined that image size of file header is 20. So that is why if we want to see the optional header RVA, we have to like add 4, add by 20, so we'll get an optional header. So 16 add by 8. So this is the RVA for optional headers. One moment. Okay, so let's move on to, let's say it is started with OB, I'm sorry, 020B. So if you can see in the optional header, it is started with OB 0B and 02. So we are in optional header section, and let's see in the structure first what it contains in the structure. So you can see this is the structure for optional header. It is like a big structure. That is why optional header has a lot of information in here. So again, we are starting with a magic number, and it is 20B, sorry, 20B, and it's over here. It is 2 byte. Move on, and it contains type of code and entry point. Entry point is really important. Where do we want to start executing our code, and all this stuff contains like this one we don't actually care about, and the only thing that we want to view in this optional header is the import directory, export directory, and also import address tab over here. So you can see it's one moment. Okay, you can see that image data directory consists of virtual address and size. Okay, like I explained before this notepad.exe does not provide API for others, right? So the export directory is 0. Let's see if we follow RVA. Wait, one moment. Okay, for import directory, because it uses a lot of API in Notepad, so that's why import directory have something in it, because it resolving other API from other DLL. And as for directory 0, if we follow RVA is an offset in memory. Let's say if I like let me open pin quickly. So let's say just imagine like this. Okay, so this is a base address. Oh my god, it's big. This is a base address, and let's see, this is the RVA. This is not entirely true, but I'm just going to let you understand what is RVA. Is an offset to, like, let's say if you want to find something over here, you have to add base address with RVA, and you will eventually reach here. So it's just an offset. Okay. Okay, so if we like jump in, like follow RVA for import directory, also can be seen here over here. So we are in import directory. I'm not going to like cover import directory entirely because it's going to take like quite a lot of time. So we can see that it resolving from other DLL like ADV API 32, kernel 32, DLL, GDI 32, user 32, and the list goes on. And for kernel 32, it is using like this API, create file mapping, and map view local file, yes, startup info, W, and etc. And user 32 ADV API, write create key, is text Unicode, decrypt file W, open process, and the list goes on. So that is why, like, so when this is like the getting into offensive tool, right, tooling, like the attackers, why they are using this manually parsing PE technique, because they want to like modify this stuff, the import table, export table, because I'm going to highlight some EDR or AV, they look in the import address table, they inspect in it. So it is actually possible For example, if I like do dump bin, my bad. You can see that there is no export. If you see imports, there are a lot of import, right, in here. So it is possible that if we like alter the import directory or import address table to become 0, so it is untraceable. So we have to manually parse and resolve the import directory and or import directory. So it can be 0 in here. That is why attackers are doing all this stuff manually, the parsing header part. So I'm guessing this is all for the boring part, which is parsing headers. And let's go back into the slide. So we're going to like enter the crucial part of the talk. I mean, it's quite interesting. So we're going to cover like 4 process injections. So please note that the process injections taught here is already known and used by many years and many people. And we are going to like cover the first one, which is a classic process injection. And it basically create a new memory region to store shellcode in a remote process, and we create thread and we execute the shellcode. Shellcode is contains like bunch of bytes that, for example, if you give a shellcode to get a reverse shell, you get a reverse shell. If you give a shellcode to pop up a calculator, it's actually a you can say it's a machine code like to execute uh, on the computer. So on the left side is our implant. Is our is the implant that we code, and explorer.exe is our target process, our remote process that we are targeting. Okay, let's say we have a shellcode in implant.exe, and second part is the first step is we allocate a new empty buffer using a virtual alloc x API. So that explorer.exe have an empty buffer in here in the memory. And the second is we write the shellcode we have in here into the buffer, and then we execute the shellcode. And next part is Ali will cover for the classic injection demo. One moment, Ali. Okay.
Yeah, you mind to share the code and explain the line if you mind?
Oh, my bad.
Yeah.
Okay, sure. Okay, let's go into the code real quick. Okay, so we can see that we have a payload in here and key, because we encrypt our payload with AES encryption, and we hard-coded all the payload and key here. And you can see this is the main function. We find the first target. We find our target process, which is notepad.exe. Let's jump into find target. Oh, I'm sorry. One moment here. Okay, so this like okay, find target function. We accept a process name, and it will look through all the using the create tool help 32 snapshot, and we look through the using the process 32 first, and we find the PID for notepad, and we return the PID. We just want the PID of the process, okay, to be used later. So you can see we store notepad process PID in this variable. So if the PID exists, we will print out notepad PID here for verbose purpose. And we open the process. Okay, and then we open the process to get the handle of the process. This is a Win API. So we provide this, why we need the PID, because we want to include in the function parameter. And we have a process handle for notepad for the remote process. And this is where the injection begins, the inject tool. So the first part, this is resolving the RTL create user thread Win API from NTDLF. So we have the function yet ready to be used. And then first we decrypt the encrypted shellcode and store it in payload. And I mean, we decrypt it. And now the state of the payload is decrypted. And then we, like I mentioned, we allocate a memory space or empty buffer in the remote process. See, we are giving the notepad process handle here, and we allocate the exact size of our payload of our shellcode, and we write our shellcode here, this one. I'm sorry. We write our shellcode here, payload, into the handle, into the notepad process at this address pointer remote code. And then we are going to create a specific thread for it to execute our shellcode. And then it should the shellcode should be executed now. So let's move on to the demo section, demo debugging section. Okay.
Yeah, so can I do it now, Aniq?
Yes.
Okay, yeah.
Oh.
Thank you, Aniq. So for the question of is the binary can be given or not, I make a Google Drive for it, but should we give it now or at the end of the session, Aniq?
At the end of the session.
Okay, yeah. So I will do the demo for the first one, which is the classic process injection. So later on, at the end of the session, you will receive this 4 binary. It only consists of the codes and not the EXE. So you need to compile later. So for this demo, for disclaimer, I'm also learning. So there might be some terms that I might not give the correct words or correct explanation. So if anyone have any good explanation, just let me know and us know in the chat. So in this first binary, we have one CPP and two H file in here. So to compile it, we can use cl.exe, which is the full name is control language. We can use it to compile C and C++. So first, I'm going to open CMD in here. Let me just adjust this. So here's the full command to compile it. Let me just get it first. If you just run cl.exe, there might be some errors because they can't find the environment's variables on certain things. So before we run this, we need to call all the environment variables that included in Visual Studio. So we can use this command to call all the environments variable in this bash script. So if you run this, and you can see the environment has been initialized for x64. So if we try to compile it again using cl.exe, there will be no errors. Yep. So here is our implant.exe. So first thing that we want to do is we want to test is it working or not. So if you just try to execute implant.exe, there will be nothing's happen because like Aniq said before, we want to inject into other process. In this case, all the binary will be injected in notepad.exe. So since there is no notepad.exe in this process, that's why there is nothing happen. So first thing first, let us open notepad.exe. So I just put it on the right side. And if we try to run the implant.exe again, we found the PID of this notepad. And if you click continue, our shellcode will be executed. And that's what we want to look at using two different tools. I'll be using Process Hacker 2 and also at 64DBG. I guess it is much more easier for us to look at and not very deep into the reverse engineering part. Also, I'm not that good on that part also. So let us learn together and we try to look into Process Hacker 2 first. So ensure that you run Process Hacker as administrator. And I'll just put it on the right side again. And let us open notepad.exe. So if you look into the process hacker, we can find there is notepad.exe process with this PID. So if you try to run implant.exe again, you can see that you managed to find the notepad.exe PID, which is correct, 5808. And this address is where the shellcode is located in this notepad. So how we can look at this, we can just copy this, right click and go into properties, or you can just enter in this process. And there's a lot of attributes in here, but we want to look at the memory section and we want to find out the base address of this in this section. So let us find it. 02BA187 200. So it should be here. And if you try to click enter or double click, you can see that here is our shellcode. And there are some message in here that will be pop out later on. So if you click continue now, we can see that our shellcode has been executed. And that's how you can take a look at the shellcode in this memory address using Process Hacker 2. And now we're going to use 64DBG to look at where the shellcode is located. So first thing first, I'm going to open 64DBG. And we're going to open the notepad.exe and just run it until the notepad is open. So now, since the notepad is already in here, we can just try to run it again. Let me close the other one. So if you try to execute this, you can see the PID is correct and our shellcode has been located in this memory. So the same thing like Process Hacker 2, but in this case, we can use ctrl-g and just locate the address. So it found the address. And if you try to right click in here, following down, we can see that we have the same shellcode that we found in the process hacker 2. So like Aniq shared to us and explained about process injection, at the end, our shellcode will be executed, and depends on what kind of shellcode that they are using. In this case, it's just a message box saying that hi from that team operator and so on. And that's the demo for the first one. Yep. I will give back to Aniq to explain the second process injection, which is in the thread context or thread execution hijacking. Aniq, are you there?
Oh, my bad, my bad. I
Yeah.
was muted.
Yeah.
Okay. Okay. So I'm going to like answer a lemon pro question first. As line 149, is it to create a user? It is not to create a user actually. This line is actually we want to resolve, right? So we have to expect our PE file or our binary does not know how where is a create user thread API. So we are saying that hey, please get a module handle for NTDLL so I can enumerate in you. So we get a module handle for NTDLL. NTDLL is somewhere located in the Windows file system. Okay, and then we want to get a process. We want our binary to loop into NTDLL.dll export table and see if we can get a process address for this API, which is a create user thread, and then we will get the process handle, process address where this API is located in NTDLL. So what is this API create user thread? It is not a to create user or anything. It is creating a new thread in the user context, in the current user context. So we can create I mean, if we create a new thread that contains our shellcode, and that is why our shellcode is executed, because we are creating a new thread that is up and running. Okay, so I can see another question, which is how do we create shellcode? Shellcode, there is already, we only use a POC tool. Like there is already a well-known tool called MSF Venom out there. Okay, can you write in chat, Ali? Yeah. No worries. Okay, shellcode can be created with MSF Venom, which is a well-known tool in Kali, or you can install it. If it is not pre-installed, you can install MSF. I mean, Metasploit framework contains MSF Venom. It can create shellcodes based on what you want to do. You want to do a reverse shell, you want to pop up a calculator, and etc. So Ali already given the link. And we can say another question. What is NTDLL used for? NTDLL contains like a lot of I mean, it is like how do I see this? It is like if you want to look for something, like some information, you go into the book. So imagine that the book is the DLL, okay, is the NTDLL. Let's say if you want to look for a chemistry element, you don't look into like a biology book, right? Because it should, let's say if you want to look for chemistry, I mean chemistry information, say what type of element this is, and you look through a biology image, you will fail, right? So no information will be found in that book. So we have to look into the right book. In this case is NTDLL, that contains at least thousands or hundred or thousands of Win API that we want to use here. We cannot use here if we don't find the API in NTDLL. Let's say we want to find RTL create user thread API. You can Google this, and there is a Windows documentation on this API. We want to look this API in NTDLL. It contains a lot of DLL. I mean, a lot of APIs in here. And we want to look for a specific API, and we want to get a process address for the API, the proc address, and only then we can use it, unless our binary does not know where, I mean, how to use this. It does not know what it is, so we cannot use it unless we get it from somewhere, from NTDLL that provide us the API. So I hope that answers your question. So let's move on into the next one. The thread context. The simple word for this is find usable thread in remote process. And we ask the thread to point to our shellcode instead. So a bit of caveat here. This technique might break your remote process. Okay, because we can call this as hijacking a thread actually. So what it does, we have a shellcode hard-coded in our implant.exe, and we find a usable thread. Normally it's a main thread. So we assume that we already find a thread in the remote process, and we allocate shellcode in remote process and the explorer.exe process, and we suspend the thread. Okay, so the main thread is in suspended mode, and in this one we get the thread context, or we get the thread context, and we modify the thread EIP. EIP or RIP stands for instruction pointer. It basically means that in the machine, in the back end, like after I execute this, where do I go? After I execute this, where do I go? So this is instruction pointer, like it instruct where to go after this, blah, blah, blah. So we are modifying the threads context, RIP, instruction pointer, instead of you executing the legitimate stuff. We modify the RIP to point to our shellcode instead, and we resume the thread, and the thread should now be hijacked and execute our shellcode instead. Okay, this might be quite hard to understand, but let's jump in to the code. Okay, so again, we find the target for Notepad. We get a PID. So we check if the PID exists. Only then we do other stuff. We get the process handle again for Notepad, and we inject. This is the function that we want to look for. Again, we decrypt. We find a usable thread first. Find thread function. We basically use this API, thread32 next, and we look through all the available threads, and we check if the current thread is equal to current thread PID is equal to current process PID, then use it. Whoever come first, and we break the loop and we return the thread handle Okay, so we now have the thread handler, a usable thread for the current process. And if it's not found, then exit the process, and we decrypt the shellcode as usual, and then we allocate a memory region in the remote process, and we receive an pointer address, and this for debugging purpose. And we write our shellcode into the region, a memory region that we have allocated just now here, and we write our shellcode in here. So now our shellcode should be in the remote process, and we suspend the thread in order for us to change the RIP of the process. So first we get thread context of the found thread. And next, this is basically a check if the current process is, oh, by the way, I forgot to mention that if it is 32 byte, this is 32 bit, and it is called EIP. If it is 64-bit binary, it is called RIP. So in this case, we are moving to the else statement. We are going to modify RIP instead. And then we are going to like modify the RIP to point to our remote process instead. And then I'm sorry, on our memory space that that contains our shellcode. And then we apply the changes to the thread, and then we resume the thread, and it should execute the shellcode. So I will give the floor to Ali to demo on this.
Yeah, thank you, Aniq.
So by the way, before I start, if you have any question or do not understand about this, even the simplest stuff, feel free to ask. Okay.
All right. So thank you, Aniq, for explaining the second process injection on the thread execution hijacking. So the same thing like before this. Firstly, we want to compile our code in here, which is C++ code. So like I said before, we need to call the environment first. If not, you will might encounter with an errors. So let's just call the environments. And now we can try to compile it using cl.exe. Since we are going to inject in the notepad exe, so first thing first, we need to ensure that notepad already open in the process. And if you try to execute it, you might get the same thing like before this, just the technique is different. So if you click on continue, and you can see the shellcode has been executed. But in this case, we doesn't see what is happening behind it. So that's why we're going to use two different tools, Process Hacker 2 and also Ad64DBG. So let us try to open Process Hacker 2. Ensure that you run it as administrator. And let us open notepad.exe. So what we want to focus on right now is on the thread. So if you look into here, just now we focus on memory to find the address. But in this case, we're going to look into the main thread, which is on this one, the yellow highlighted color. And if you look into the state right now, it's not suspended yet. So if you try to, let's just put on the right side and open the threads. So if you look into this state right now, is not suspended. And if you try to run implant.exe now, you can see that the main thread has been changed from the other one to suspended. Just like Aniq said before, the thread has been suspended. You can see the verbose in here. So if you try to click continue now and click another one, it will resume the thread and our shellcode should be executed. So this address also the same thing like before. You can just open the memory sections and look at the address, which is in this case is 001820A9 2. Yeah, because already suspended and it's very close to the notepad SE, so you might not find it. But yeah, never mind. So now we're going to look at 64dbg to look at the tracks also. So now let us open at 64dbg. And we're going to open notepad.exe because that's where our shellcode will be injected. So just click run and until notepad.exe open. So now we're not going to look into this much, but we're going to look and analyze the threads. I'm just going to make it open a bit more like this. Oops. Yep. So before this, we look into the CPU section, but now we're going to look into the thread section, where in this case, the main thread is not suspended yet. You can see the RIP also is not changed into our shellcode address. So in this case, you might be able to see what is actually happened. I hope that you can be understand more what's going on. So if you try to, let me just clear this one and execute our implant.exe, just focus on this one. You can see that right now it's not suspended. If you click run, you can see the main thread has been changed to suspended and the RIP is not been changed yet. So right now our shellcode is located in here. So if I go into the CPU and just look into this address and follow into this dump, oops, you can see this is our shellcode. So right now the threads should change to this address, which in this case not yet. So if we click continue, you can see this address is the same this one, so which means that the thread has been changed to this RIP. So if we just go double click, you can see the RIP has been changed to this address, which have our shellcode. So if we try to resume the thread, if we try to execute our shellcode in this address. So if you click continue now and look into the threads, it will change to normal, but still the RIP has been changed to our shellcode address, and that's how our shellcode has been executed, and we get our message box in here. So that's the difference between before this and this one, why we hijack the main thread, and that's how our shellcode has been executed. So I hope that makes sense. I will give back to Aniq for the third process injection using map view. Yep, give back to Aniq.
Okay. Or you want to continue? That's all. Okay.
Yeah, that's all.
Okay. Okay. We have a question like, how do implant.exe able to find notepad? So there is this function called find target, and again, it actually look all through the process using the. So let me go one by one. Okay, we create to have the two snapshot. We snapshot all the process, available process, and we put it into a handler. And then we loop through all the process available. See, we loop through. We create a while loop, and we loop through. We compare if the PE32 SCS.exe file, and note that this should return a process name. Let's say we want to look for what process? Let's say Firefox, and process name is Firefox.exe. So I'm going to like create a new line. Okay, so in case where if the proc name, which is what we are going to look, we gave here notepad.exe, right? Down here, see, we give notepad.exe, and let's say if the first loop, okay, the original we want to look for this one. So the first loop, we found a Firefox.exe process, then skip it and move on to the next process. This will change if and next is ns lookup. No, it's not the same. It's not what we are looking for. And the next one is notepad.exe. Okay, and then if we found notepad.exe, then it will return PE32 process ID, which is should return the PID of notepad, and we will break the loop and we return the PID instead. That is how we found the notepad.exe process. We will get through the PID of the process. Okay, about the this one we do not create a new thread. We use a already uh, pre-exist, we see a pre-exist thread in the process. So just for your note, what is the difference between a process and thread? Process is entirely like a different memory region. They use a different between process. They do not share memory space, and thread share the same memory space. For example, for an easy example, okay, thread only exists in their own process. Okay, for example, if you open Firefox, that is you opening a process. If you open a new tab, like you open a multiple tab, one tab, if you open new tab, a new thread will be created. Okay, so that is how to differentiate between thread and process. Thread live in a process, and process inter-process does not share memory space, but thread can share memory space, something like that. So thread only live in the process. They cannot like access other threads in other process, etc. Like, okay, I hope you understood. I might be explaining it wrong, but that's the main idea of thread and process. Oh, okay. Okay, we're moving on to the next one. Oh, okay. We have a 5 minutes coffee break actually, so we will continue at 10:11. So let's take a short break, just in case if me myself is overwhelmed right now. So let's take a quite a short break and see what we have learned. Okay, feel free to ask if you have any other questions in the chat. Okay. This kind of stuff is quite like Advanced, to be honest, me and Ali just we just this is actually out of our comfort zone, and yeah, we try to share what we have learned before, but this is not actually our niche. But hopefully you guys understand what we explain. So yes, I think Ali will like uh gather all the txt into a link, and he will share later.
Yeah, I
Yes,
will share the link at the end of the session, right, Aniq?
yes, yes.
Okay.
Or 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 maybe you can share it now.
Okay. Let's talk about it too, but yeah,
Okay,
let
okay,
me
okay.
just maybe you can like hands on this
Yeah,
one.
we all
Yeah.
can look together. My bad.
No worry, no
Uh,
worry. Uh, Let me just get the link. Um, oops. Anyone with the link? So let me know if the link can be opened and you can download the zip file. It should contains 4 folders inside it with only the code itself and not the ESE. So you try to compile it by yourself and get the ESE.
if you want to like hands-on or anything, we strongly suggest to run it in a isolated
VM,
environment.
yeah.
Yeah, so not in your host machine. And also if you compile the code, uh, uh, but try to not like upload it, the compiled version of it somewhere on the internet, or maybe virus filter. So maybe don't try to upload it. Just yeah, because this code like has some of the AV still not flag the code. So maybe we can like don't distribute it on other place, like the disclaimers. We can store it on our local machine only. So do you want to move on now, Ali, or
Yeah, if everyone is okay, then we can continue. But yeah,
okay? So let's move on to the next one. So map view. Map view. Okay, map view is quite different. Uh, you you remember that the last two process injection techniques, we wrote our shellcode in the remote process, right? But this one is not like that. But we let's say in the line I explained that it creates an interprocess section views, and the remote process has access to view our shellcode remotely. Like we do not like write, I mean, copy our shellcode into the explorer.exe or something like that. We read it like remotely through the section views. Okay, and the first step is actually by creating a new section. So a new region of memory. It's actually a new region of memory in our local process, implant.exe process. We create a new section. And then in order for us to like modify the section, we need a view. So we create a local view first. And we copy our shellcode to this section through local view, because we cannot copy directly into section. We have to copy it through local view. And then next step is we create a remote view. And remote view can read shellcode from this section from our implant.exe. And next we execute the shellcode. So we do not like write it somewhere in the memory. It's in remote memory, in remote process memory. We access it and we create a thread for our shellcode. Let's jump into the code. So if you have a question, please ask for this one, okay? It's called map view. We are mapping the shellcode remotely. For map view, so again, we find a target for Notepad and we get a PID process ID for Notepad.exe. And if the process is found, only then we do other stuff. Again, we get a process handle for Notepad. And we inject view in here. Okay, so for this one, again, this line is the same as previously. We want to get anti-create section API in ntdll .dll, and we get the proc address for create session in ntdll, and now we can use it. So we now create a section that has all access, and we store the handle of the section in h section variable. Okay, we create a section for a length of that fits our shellcode. And then next, in order for us to write our shellcode in create section, in this section that we just created locally, we have to create a map view to that section, a local view. So we create a local view for the section for the current process. Do not create on remote process, create on the current process. And we store the pointer to local view, p local view. So we store the address in this variable, okay? And then only then we can copy our shellcode to local view, and this will write in the section we have created before this. Okay, so assume that now our section now contains our shellcode, and now we use the same API as MapView, but instead of create before this, we create in the current process, and next is we create in the remote process, the hproc. Remember hproc we get from open process of Notepad. So the process handle, process handle. We create a new remote view there and store it in the variable. The address we store in the preremote view variable, and we give it a page execute read permission. So if in the Ali will show, if in the memory, it will show that this memory page is Rx, read and execute only. We do not use normally. We can also use give all permission, like page execute read write RWX, right? All, but this would normally flag like AV or any EDR because of the normally memory does not contain like all the permissions. RWX is a red flag actually, so we only provide like read and execute. and this is for debugging purpose. Ali will show after this. And we create a thread for the current user context for the remote process. And we get the shellcode from the map view, from the remote view. So we do not write the shellcode into the remote process memory space or anything. We just access it like remotely, like view from the view. And then we store it in a hash thread, and then we execute with wait for a single object. So the shellcode should be executed by now. So I guess Ali can take the show. Okay.
Yeah. Thank you, Aniq, for explaining the third process injection, which is map view. So now we're going to look into this binary tree. So if you already download the file and you have any encounter on compiling the code, let me know. I just want to let you know that you need to download Visual Studio, if I'm not mistaken, to ensure that you can compile using cl.exe. So now the same thing like before, we need to compile it first, but in this case, I already compiled. And then we want to see, is it working or not? So we can just open Notepad.exe first. And I'm going to open binary tree folder. And let me just open here. So if we try to run implant.exe, the same thing, just behind is difference since we are using a map view technique. But the shellcode is also the same. You can see this message box. So now we're going to look into Process Hacker first. So let me just open Process Hacker 2 and show you run it as administrator. And let me just open Notepad.exe first. And now we're going to look into two binary, the Notepad.exe and also implant.exe, to see where's the map view address for local and remote, and where's the payload address. So right now we have Notepad.exe. So we can try to run implant.exe, and it found the PID of Notepad.exe. And right now, let's open implant.exe first. And we try to look into this address. Payload and also local view is what will be located in the implant.exe, and the remote view will be located in Notepad.exe. So if we take a look at this payload address, which is 007F, let me just get it to it first. 7F. Where is it? 7F89. Six. Is it this one? Let me just double click. Yeah, this one. Like Aniq said before, you can see it's not a full write permissions. It's only read and write. This is the payload address. So if we look into the local view, which is 1B87, 1B87, 62D, which will be in here. It's also have read write. And if we look into this address, it also have the same shellcode, just like Annie explained before. And now this is the local map view, right? So if you look into the Notepad.exe and try look into the remote map view, the address is 239. We'll just get into this first. 1C6A, 91C, 6A. Yep, this one. And the permission is RX read execute. Before this, in plan we see is read write and not execute. So we have RX in this map view. And if you look into this address, it also have our shellcode. So that's how we can see in process hacker 2. And if we run it again, we can see our shellcode has been executed. It's the same thing, just that it's using different technique behind it. So now we're going to attach Notepad ESE. And also I'm going to open another X64DBG to open implant.exe. So let me open this one first. Notepad ESE, and just run it until Notepad is open. And then I'm going to open implant.exe in the right side. So it should be in here and this one. So let's just run it. And we can see in here, the Notepad PID is the same. This one and this one will be inside the implant.exe. So firstly, we try to take a look into the payload section. And we can see in the DOM, we have our shellcode. So if you look into the local map view, it should also have the same shellcode. So we just find the address, take a look, and follow in DOM, and we can see our shellcode in here. And also for the remote view, you should also have the same thing. So we just follow in here, look at the DOM address, and yep, we have our shellcode in here. And if you look into the threads, it should also be the same, but in this case, we're not going to we not be able to see directly the thread suspended. So if I click continue now, it suspended at one time because we're not stopping it in this code. So but at the end, the shellcode will be executed using the map view technique. And that's how you can take a look using S4DVG and also process hacker 2. I think that's it for the map view demo. I will give back to Aniq, or if you have any question, please let us know. And yep.
Okay. We have a question. Okay. Okay. Basically, like payload, local view, and remote view is where shellcode is located. Technically, yes. Because we we don't want to like copy the shellcode there. Instead, we map a view for it. We create a local view to map the shellcode, and we can receive it. So in here, see, initially the shellcode is here on the implant.exe, and then we create the section, and we cannot directly copy into the section, and then we create a local view. Only then we can copy it into the section. So now our shellcode is in the section, and local view should have our shellcode now, and remote view also should have our shellcode now, because they are reading from the section, right? Local view and remote view. And now this three part, the P load is here, is on the shellcode. The L view, local view, is on this one. It sure contains our shellcode because local view is also reading from the section which contains our shellcode. and the R view is reading from this also. Okay, great. Then we execute the shellcode. You should notice just now Ali show on the thread part. We use a create user thread, right? So new thread will appear. So maybe Ali can cover on that after this. Like create user thread, we can see a new thread appear. The execute shellcode. But after this, okay. Let's move on to the last process injection technique. We call it APC, short name for it. It's an asynchronous procedure calls. This is a well-known technique used by offensive tool or also by developers, because APC is needed in like every application that we use. So I'm just going to like explain it like we experience on our daily life, right? So if asynchronous is where you want to like do other stuff while doing this stuff, right? We do it asynchronously. For example, if you open a file, let's say you open a Word, Office Word, right? Microsoft Office Word. Let's say you want to open a docx file, a template or anything. You click File Open, right? You click on the top left side, File Open, and the system it wants to like look for other stuff. I mean, look for the files available in the file system, and it should take quite a long time. And in this case, if we want to wait for the process to finish, it is like quite nonsense, right? So we want to do other stuff while the system is searching for files. And that is where the APC comes in, where there is a APC queue, and yeah, I will go through it. So that's a basic idea. So we have a shellcode in implant.exe. So the first step is we want to find a thread in the remote process. So we already found thread X. And second is we copy shellcode into our remote process, copy it anywhere. And the third one is we add APC object to APC queue. Okay, we create an APC object first, and we add it to threads APC queue. Okay, so in every thread, there is an APC queue. Okay, so keep that in mind. In every thread, there is an APC queue. So if we create an APC object that contains that will point to our shellcode. One moment, I will show in the code after this. So the next one is we call it wait and pray. Okay, because we have to like wait for this APC queue to be executed, like our APC object to be executed in the queue. Okay, when will this happen? This is called an when our shellcode will be executed if our thread is entered an alertable state. So okay, for example, we have these 5 APIs, right? Sleep X, signal object and wait, message wait multiple object X, wait for multiple object X, and wait for single object X. If either one of these are executed by the system, then our thread will enter an alertable state, which will execute our shellcode. Okay, so again, we find a usable thread and we create an APC object. And this figure is not entirely clear actually. We create an APC object and add it to APC queue. And now we wait for one of these functions being called, and our shellcode will be executed. Let's jump right into the code. My bad. APC queue. Okay. So this part, okay. So we copy our shellcode here. I'm sorry, we allocate a memory space for this length, for our shellcode length in notepad.exe process, and we write our shellcode into the allocated memory in notepad.exe process, and we queue user APC. We create a like we use a thread. My bad, I skipped this part. We have to search for a thread first, and we will use the thread and create an APC object. QUSE APC will do all of that step and create an APC object, and we put this in APC queue. Okay. So you can see in the comment section, thread will enter an editable state when one of these function is called. So note that when it enters editable state, our shellcode will get executed. See, we have pointed to our shellcode here. So the memory that contains our shellcode. So in the back end, in the system, let's say if you click file open, one of these function will call actually to trigger our APC object, to execute our shellcode in our case. So if you have question, please please ask. Okay, this is quite hard to like visualize. Maybe Ali can show first. One moment. Okay.
Yeah, thank you, Aniq. Even myself also still have a bit difficulty on learning this, but Aniq just teach me also on how to understanding this. But never mind, we are learning, so there's nothing wrong with that. Let me just get this thing. Okay, so this is the final process injection, which is APC, asynchronous procedure calls. So in this binary demo, it's going to be a bit different because we need interaction with the Notepad ESE. So I'm going to show you the binary. I think I already compared it. Yep. So first thing, we need to open Notepad ESE. And I'm just going to click on the left side. So before this, if we execute the ESE, we can see we found the PID and the address. This is the verbose part. And if you try to execute it until the end, supposedly it should give us the message box. But in this case, we need some interaction with the Notepad, or just like I said before, wait and pray. The shellcode has been executed. So if you're using Notepad ESE, there is two ways. If what I've known, by using file open, you can see that our shellcode has been executed. So I will try to explain why behind it after this. Then for the next one, like I said before, there's two ways, file open or file save. So if we execute it again and try to open file save, it also will execute our shellcode. So what's going on and why when we open this, it give and execute our shellcode. So we're going to use process hacker first, which you need to run as administrator. And then I'm going to open Notepad ESE first. And if you look into the process hacker, you should see Notepad ESE. And you just double click it first. And we're going to look into the threads. So if you try to execute it, there is nothing happens. The thread is still the same. Only the shellcode is located in this address. So if you look into the memory with this address 2970A to 970A. We should be in here. Yep, it's read and execute. If you go into here, here is our shellcode. But in this case, if you click run to the end, there is no shellcode executed. But we know for sure that our shellcode is located in that memory address. So what happened is when we try to do file open or file save, if you look closely in the threads, it will open another new threads. So what I've searched internet, they said that the reason why our shellcode is executed and run by using file open or file save, because when the main thread creating a new thread, in that new creation of new thread, it recalls the APC dispatch routine, and that's how our shellcode has been executed. And yeah, if I'm not mistaken, Aniq said that we can forcibly do that to call the to call that APC, but in this case, in this demo, we're not going to do that. We're just using Notepad to interact with that. So yeah, that's it for process hackathon. So I'm going to show the SC4 DVG last one, and yeah, it's also the same thing, that just using different tools. But yeah, I'm just going to show it to you guys. So the same thing, we're going to attach Notepad ESE. If you have anything to add, anything, just let me know. And just feel free to add. Yeah.
Maybe we have a question like, can we point to a different process other than Notepad? Maybe after this, you can like change your
Okay.
target process to other process.
Yeah, we can do that. So now, oops, I'm sorry. We need to open Notepad ESE. This one. And just run it until we have our Notepad running. And now let us just execute our implant. And if you look into the thread section, just make it bigger. And just click run until the end. And there is nothing happens. And if we try to use file open or file save, in this case, you can see it's suspended, and at the same time, you create a new threads. So I need to click it because we are using debugger. So just click run. Yep, at one point, it's not suspended anymore. And we can see our shellcode has been executed. And that's how you can use process hackathon and also add C4 DBG. So if you like to do more, you might take a look using IDA Pro or Ghidra to look into the code, what kind of API that it calls and it do. I think that would be the best exercise that you might want to learn with this binary. So you want to change the process, right? Instead of Notepad ESE. So we need to change the code. Yeah, what would be the best process should I change any?
Okay, so maybe I will like, I'm not an expert on this, but this is based on my experience, what I've been through so far through the from what I've read, the best process, right? Okay, why do we pick Notepad.exe? So just a note that Notepad.exe is not entirely an obsessive, because if you basically we are injecting into a remote process, right? We do not create Notepad. Like our implant.exe does not create Notepad. We can do that, but instead we want to find an existing process. So normally targeted, let's say in the computer, Notepad is not open, like not open, right? People would not just open Notepad and left it open on the workstation or server. Maybe maybe normally people would like inject into explorer.exe because explorer always because this when you open Windows, explorer.exe is a must to be run in background unless you cannot see the GUI. And I mean not the GUI, I mean things that you can click, the file browser and etc. And also I used to like click on NS lookup, something uh that is like all people always open it in the background, right? And NS lookup is not a good option unless you spawn a process for it. uh some people, if they have a high integrity level user, they will use a high system level process. For example, WinLogon. WinLogon is used uh, during when you log in into a computer. WinLogon is used, and let's say if uh, but please note also that the some of the technique that we have shared just now, it might break the process. It might cause crash. And uh and then next maybe you can try other option. Should be smart logon, smart screen, I'm sorry, not smart logon, smart screen, something related to that. But for now, the best process that we can choose probably explorer.exe, Ali.
Okay.
Yeah.
Yeah, I think like when I close everything and open process to we can see that Explorer ESE is running on background. So yeah, I think that would be the best ESE that we can try it for now. So let us change the code. Let me just change it. It should be binary 4.
Or maybe Ali.
Yep.
We have a question: if we inject our shell code, do we gain admin level privilege? Maybe you can try that too.
Oh, okay.
It's okay. We can try. We can try.
Yeah, we can try.
We haven't tried this in rehearsal, but we can try.
So we want to change it to explorer.exe. So just change the verbose to so that we can see. And then I'm going to compile it again. And here's the environment calls. And use the commands to compile it. So now I'm not going to open Notepad.exe because we're not going to use that. So since we know that Explorer.exe is still running on background, so we can just try to execute it in plan.exe and let's see what's happening. So if you try to look into Explorer.exe properties, memory, I've not tried this before, but let's just see together. Let's see the address 34800. 34800. I think it's this one. And yes, we can see our shellcode in here. So now if you try to click run, so is this where the session will and pray and or do
Oh
we
yeah,
need?
we are using APC, right?
Yeah.
Maybe try
Oh,
like open file browser.
okay, yeah, I can try to open file any file. Let me just open a new window. Oh, file browser, you mean like
Maybe search something.
okay,
Search.
let me search
Or else
for
we can use a classic injection. Is it executed?
I don't think so. Should I try open Internet Explorer or anything?
Maybe you can try change process in the classic injection.
Okay, yeah. Let me just change the code again. Yeah, it should be this one. Change into for Explorer. See, try to compile it. And now if you try to execute our implant.exe, yep, we get our shellcode executed, even though that we're not open notepad or anything, because Explorer still is running on the background, right, Annie?
Yes, yes, yes,
Yes,
exactly.
okay. So yeah, it depends on where you inject and how it is it running on background or not. Yeah. So what are the next thing that I want to try?
Maybe you want to answer what are the difference between using binary 1 to 4 for implant exe.
Difference using binary one for, so one is using classic um, process injection, right? And for four, you're using APC. So it's a different technique like Ani explained before. So what we are trying to do in this demo is the same thing using process hacker 2 and SC4DBG to look where the shellcode located. And for APC, you might want to see the threads. Uh, when you using Notepad ESC just now, you need to open file open and also file save to get that alertable state, and it will execute our shellcode. But for traditional FC injection, I think as long as the process is there, you might be able to get the shellcode executed, and you don't need to force um, the editable state or using Notepad just now to use file open or file save. I think that's the difference between the first and the fourth binary. Yep.
Okay. Oh, Farid said that maybe we can force the four functions. Uh, yeah, we
Yeah, we have tried it.
we will try it maybe off screen because
Yeah.
we want to like make audience understand the APC procedure, so that's why we didn't force it.
But yeah, I think it's possible, but you just need to make the codes run well, I think.
But by the way, for the difference between 1 and 4 for implant the exe, I mean 1 to 4, you can choose any of these techniques. Depends on your target, your target, or let's say if you're working for a client, so avoid using a process that might break uh, the remote process thread or something, because yeah, it's other people's property, right? And then maybe the best thing is try to use like classic injection into a remote process, and yeah, the difference is just the technique, but the outcome is just still the same. We will
Yeah.
execute our shellcode. So I guess that's it, right?
Yeah, I guess that's it. The relatable state you can add in here, right? If you like to force the
Um,
relatable state,
yes, yes, yes.
yeah, in this part. So you might want to maybe do some homework and study on how you can force it. You might just want to add in these sections and see if it's working or not.
Okay.
Yeah.
And then let's move on to the Q&A before we end our session.
Okay.
So if you have any question, please feel free to ask Ali.
And I need to, yeah.
So I've given the link. Also Ali have given the link. There are there are a lot of other process injection techniques or other techniques to like execute shellcode, other creative stuff. but we are showing like just 4 of it. So there are a lot of other stuff that is more advanced and quite low level.
Yeah.
But yeah, you guys can take a look at the link that we have shared.
I think the links that I shared, the Elastic CO, that one have if you like to try open it, any that one.
Okay.
Yeah, this one have more informations, and I think all the process injection that we explain and I need explain also in here. So you might want to take a look at this as your reference when you play around with the binary itself. So for Farid question, right? We begin high privilege access
Oh
if
yes.
if we inject the implant on a process run by high privilege account. Um,
Do you want to try it? Just execute as admin. See.
okay, but how can I like let me just open it because we are not tried it. So yeah, let me
Maybe
try it.
try classic injection and execute it as admin.
Oh, okay. Plus injection.
Use notepad again
Okay.
to avoid.
Do you want me to run it this as admin or implant it
No,
as admin?
notepad is as
Normal.
uh, we will gonna have reverse if you inject the implant into process run by try run notepad as high privilege account.
Okay. Because if you do like a reverse shell or anything, you might see using UMI and something, right? But in this case, I'm not sure how you can
So
see it.
if logically speaking, a normal privileged user does not have like permission to write on her admin level privilege, right?
Okay.
But are you login as administrator?
Right now, yes, I think so. But I can open this as admin just now, but I just open it again as admin. So right now I'm running Notepad as admin, right?
Yep.
So if I try to, but I need to change the code again. So let me change the code. I need to run it as Notepad ESE. Also the same thing here. And try to compile it again.
So how do we know if we have to get revision, right?
Yeah, I think that's the best scenario that we can try to check. Is
You
it?
want to test revision?
I don't have my setup now, so yeah, I'm not sure if I can do that for now.
Okay, okay.
Yeah, yeah, it might take a while if I set up it.
How do we do this?
Or do you have your environment set up already?
Okay, okay.
While I do this, maybe you can try to set up it if it's okay for you.
Sure, sure. Can.
Okay, so let me just see this. We need to compile it first and execute it. So now we have the ESE and we have the Notepad running as admin. Just make it like this. Okay, so
Can you try who am I real quick? Who am I? Who am I?
right now,
Yep.
okay.
Okay.
Or maybe you can. Is there any like shortcut that to open from CMD? Maybe we can test that if you have the shortcut for that one.
Yeah, sure. Maybe you try first.
Okay. So if you try to execute implant the ESE, um, continue.
One moment, yeah, one moment. Okay.
So yeah, we can see is it run as, but we can inject it, and that's what's going on lah. Yes, maybe if we try to,
Maybe because you are in the administrator, you can
that's also might be the case. Yeah. So we also not sure about that. But yeah, it's a good one to try. Maybe uh, if you have the setup environment setup ready, maybe you can try it. And but yeah, I need
Uh,
just
you want to prompt a CMD?
yeah, yeah, I think that would be the best one.
For while we are preparing the environment, if we can, maybe some of the audience have more questions. Do we have a question?
Oh, okay. Let's see. So how you guys started more development or this red teaming things? Yeah, I can try answer it first. For me, I think it's still new for me. I'm not into red teaming much yet or malware development, but I think it's a good knowledge you can gain. Even as a pen tester, you might involve with red teaming in the future. So that's why I start to learn about red teaming a little bit. I think this is a good start of learning process injection and try to code and play around with debugging to see what's going on. Is it in the Windows kind of things? It's a bit struggle and hard to learn because it's quite low level kind of things. But I guess if you keep trying, and also if there is workshop or anything, just join. Even myself, by doing this, also still learning. So I guess we are in here to learn. So it's a good community. So hopefully there's more coming with this kind of sharing sessions, so we could learn together. Yeah, I think that's it from me. How about you, Nick? If you want to share it, or when you are free later on, if you see set up.
Okay. Just I don't have much experience on red teaming. Uh, we don't actually how do we start? Actually, we started to like code malware actually, or something like uh, botnet or ransomware or something like that. But it is for learning purpose or for POC that we run locally. And from that, we from the project that we start, we learn a lot of stuff along the way. Normally, that is my technique to learn about something like have a project and learn along the way. Yep, that is I do not specialize in malware development, but that is what keeps me going to learn about this. Yep. Ali, I will share the share code.
Okay, yeah, hopefully that is working. You give it in. Uh,
One moment.
okay.
Have you received it?
Yes. So I just change the payload and key, right?
Yep, yep.
So let's see. Is it working or not? Um, Moment. So it's the payload, and here's the key. So let me try to compile again. This one. And let's see the moment of truth. Is it working or not? I'm going to run it as normal one, not as admin, but I guess this is an admin user, but let's see first. So here's our notepad, see. So if we execute implant.exe, supposedly we should get a CMD prompt. And yep, we do receive it. And right now,
I think maybe you create a new user. This last
okay,
one. If not, then you guys can try it on your yes. Just open a CMD as admin, then create a new low privilege user.
okay.
Yeah, net user anything slash add and user username before add.
Okay, so I just made low brief, something like this. Is it
Okay.
like this?
No.
Only
Remove
that.
the yep
Okay.
this one and net user low brief asterisk asterisk. Enter the password. Enter and yeah, enter the password. Okay, maybe try run as.
Wait, this one, okay.
Yep, run as slash user colon low brief slash profile cmd.exe. Yep.
So if I use UMI now, I'm low brief, right? So let me just get into this binary. Okay, let me just in humans. Documents. See this. Yep. So if I run this as admin, the notepad, run as admin. So right now we are the brief user. So if I try to execute this one, hopefully it's working.
Yeah.
So this tell us that it's not. We
It's not.
can't we can't
Yeah.
do that. Yeah.
Yeah. Logically, a low privilege user cannot access process that is spawned by an
Yeah, makes
higher
sense.
integrity level.
So if
Yep.
I just run this one, yeah, because
Still not
maybe
working.
yeah, even with low brief user.
Oh, try to do you use run as.
Oh no, that one not.
Try notepad.exe.
This one, right?
Yeah, the top. Yeah. You have used the command.
Oh, okay. This one is empty. I mean,
That one. Above MI. The one that you run CMD, right?
oh,
Use the run
okay.
notepad.
Okay. It's the brief and not that. So if we um, run this one, yeah, it found what it have, and we get the shell as that user. So which means that it's not possible, I
Yes,
guess.
yeah,
Yeah.
yes. As long as uh if you have a user, let's say the Hojin user, it is under the local administrator group, so it should have
uh,
permission to inject into the high integrity.
I see.
Okay,
Yeah.
so I guess that prove it. Thanks so much, Ali.
Yeah. Thank you, Aniq.
Okay. So I guess that's all from our side. And yeah, thank you so much for
Thank you,
listening.
everyone.
We appreciate it.